Hello, in this video, we will be covering calibration over CAN. To calibrate the WAS over CAN, a soft reset request must be sent. Then, the CLS must enter WAS calibration mode by sending the enter service mode message and specifying WAS calibration. Once in WAS calibration mode, the position capture request must be sent for the left, right, and center positions. The captured positions and status can be read from the position capture reply. Once all of the positions are captured, the parameter update request must be sent. At this time, function blocks for these messages are not available, but can be replicated by transmitting the data that relates to each message. This CAN transmit block is used to send the required messages for spool and WAS calibration. This is an example of how to implement WAS calibration over CAN using guide. First, the soft reset message must be sent. The soft reset message is triggered by a button press. This button press also initializes the state machine used to control the calibration states. The state machine allows the correct data to be transmitted based on what state of calibration the CLS is in. First, the enter service mode request must be sent. Once in WAS calibration mode, the user will be prompted to capture the left, right, and center wheel angles using a button. The captured positions and status can be read from the position capture reply. Once all the positions are captured, the user must accept and save using a button to send the parameter update request. Traditionally, spool calibration must be done through Service Tool. However, spool calibration can be done using CAN messages. This simplifies and accelerates the calibration process. There are 5 main steps to calibrate the spool over CAN. First, a soft reset request must be sent to the PVED CLS so that it broadcasts its address claim. Then, the CLS must enter spool calibration. This is accomplished by sending the enter service mode message and specifying spool calibration. Once in spool calibration mode, the auto calibration must become armed. If the valve is set to EHIH and IMD in Service Tool, spool calibration will become armed automatically. If the valve is set to EHIE and STW, then the STW CAN message must be changed to appear in use. The STW message must have a change in angle and velocity greater than the STW in use thresholds, and then stop moving to get to the armed state. This could also be done manually using the steering wheel. After the calibration is armed, the start command needs to be issued. Before issuing the start command, the wheels must be straight, within a tolerance set by P3804. The calibration status and errors can be read from the calibration status message. Once the calibration is complete, the parameter update message must be sent to save the values to the EEPROM. Once the parameters are updated, a soft reset message can be sent to move the controller back to operational mode. This is an example of how to implement spool calibration over CAN using guide. First, the soft reset message must be sent. The soft reset message is triggered by a button press. This button press also initializes the state machine used to control the service mode states. The state machine allows the correct data to be transmitted based on what service mode state the CLS is in. First, the enter service mode request must be sent. Once the CLS is in spool calibration mode and armed by moving the steering wheel, the start calibration message is sent. The calibration status message then needs to be received and broken down. Once the calibration is finished, the parameter update request is sent. If spool calibration must be done manually, for example, in a multi-axis system, the direct output control mode can be used. Once in direct output control mode, the direct output control request can be used to request a spool position and turn the cutoff valve on and off. The direct output reply can be used to read the direct output control status. That is all for this video. Thank you for watching.